Well, thank you for the nice intro. So yes, as was mentioned, I'm originally from Belgium. I've been in the US for the last about 13 years at Microsoft, where I've worked at a whole bunch of different teams. I joined in the .NET Framework team, where I worked on WPF. I also worked on the installer for .NET 3.5 Service Pack 1, I believe it was. Did a bunch of things with dynamic, also some stuff around LINQ, language integrated query. Moved to the SQL Server organization, where I worked on event processing systems. One thing that came out of that was RX, but we did a whole bunch of incubation over there for a couple of years, and then I moved to the cloud organization to work on distributed systems. And for the last couple of years, I've been working on an edge computing platform, which is not released yet, but it has to do with being able to run compute on very tiny devices. And oh, I think it seems I have to admit people into the room, but that's fine. So yes, I've been working in embedded systems for the last couple of years. So I've been kind of sinning because I had to do a lot of C and C++ for those couple of years, but I've been lucky enough to have the opportunity to kind of keep following the evolution of C# pretty much since the very start. Before I joined Microsoft, I was an MVP for C# for a couple of years. And before that, I actually worked with some internships at Microsoft Belgium, where I developed the first ASP Plus website. That's the precursor to ASP.NET. And so I actually had an opportunity to work with C# all the way back in the year 2000, before the first betas came out. So I've been with the language ever since the beginning, except for the 0.x releases that were purely internal. And so I'm very happy to be able to share with you what's happened for C# 9. And so I've actually pulled up the language status over here because, well, there's nothing anymore that's not visible to everyone. Everything is happening on GitHub. We have two repos. We have the C# lang repo over here. That's the place where discussions happen about new language features, and where we keep the notes of all the meetings from the language design team all the way back to 2013. We see the notes over here, and pretty much everything that's been discussed in the language design meetings is publicly available. So here you can see the things that were discussed literally a week ago about new features coming for potentially for C# 10 or beyond that even. In the issue tracker, you can also go to put proposals. If you have an idea for something or something you don't quite like in the language, you can see this. There's a ton of things floating around here. There's a lot of activity of people talking about all these things, and they will potentially picked up when they get this proposal champion thing on top of it. It means that somebody from the language design team will actually pick up that feature, says we'll discuss it in the language design meetings and see where we can get it, if it fits in the language, yes or no. And then on the other side over here, and then I'll go into demos, I have the Roslyn repo. That's where the development happens for the C# compiler, including the language service that sits in Visual Studio. Pretty much everything happens over here. You can, of course, download the code and compile it yourself and play around if you like. But you can also use it to see the status of different features being implemented. And so you see C# 9 is pretty much all done. Everything has been merged, as you can see, into the branches for 16.7. That's Visual Studio 2019. And on top of it, well, you can already see for C# Next, the development has started in the master branch. So there's a bunch of things already going in, but there will be much more, of course, coming in the next couple of months. So let's actually zoom in to C# 9. I have Visual Studio installed over here, Visual Studio 2019 preview. I literally did the update yesterday night to the last release. And so let's just dive in and create a little console app and have a look at what we can do over here. I always do live demos, so it's always a risk. I've never done it in conjunction with Zoom being recording, so I'm not sure where my CPU is going right now. I don't want to blame any particular program, but this seems to be a little bit slower than anticipated. But we'll just sweat it out for a second. In the meantime, I'll just briefly go over over the list of things here. There's a bunch of big features and a couple of smaller ones actually. I would actually highlight the most important big feature to be record types and some improvements around pattern matching, which we'll talk about today. And then you can see like there's a whole bunch of smaller things, things like lambda discard parameters, for example, things like static lambdas. I'll briefly talk about these. Target type new. These are all things that have to do with making the language less verbose in certain places. And so I think we can continue now. Yes, here we are. Things are starting to line up. I'll be using two things today. I'll be using Visual Studio on the one side and also be using ILSpy. If you haven't used ILSpy before, I highly recommend you to download it. ILSpy allows you to decompile a piece of code, and because ILSpy doesn't quite know C#9 yet, and they have this nice menu for decompiling to older versions of C#, we can actually use it to take a look at a piece of code and see like what would be the equivalent piece of code you would have to write in an older version of C#. And that's actually the ideal way to sort of seeing what certain language features translate into, because the majority of language features that we'll talk about are pretty much very concise syntactic sugar over something you could already do in the past, but it was incredibly tedious to do so. There are a couple of things that are exceptions to that. Ever since C#8, we have started to evolve the language together with the CLR. So we can actually rely on changes in the runtime to make certain things work better as well. And so we'll see a couple of these coming up as well. So the first thing I'm going to do over here is I'm going to change this this beautiful console app that I have over here, to .NET 5, like this. I can also do that through the property window if I would like to. And now we can actually use C#9 features. So it comes together with .NET 5. And so the very first thing I would like to take a look at here is like, what's the smallest possible program somebody can write? And when you take a look at this automatically generated code, well, there's quite a lot of ceremony. We have 12 spaces sitting over here in order to be able to write, console write line, right? So there's a lot of cognitive overload, to just get started, especially compared to some newer and modern languages. Well, C# is modern, but it has a pretty long legacy as well. So what can we do to make this experience a little bit better? And on top of that, we actually do have this thing called CSI, C# Interactive, at the command line, where you don't have to have that whole ceremony to simply say hello. You can just do console write line hello, and things will just happen top level over here. So why do we have to have all this stuff going on? So I'm going to present you with the smallest possible C# program that you can write now in C#9, which is just semicolon. What's happening here? Well, this thing just has a single line, which is a statement. Semicolon is a statement. It's an empty statement. And this is actually called top-level statements, meaning that at the top level of your program, you can simply have statements, like calling methods, ifs, whiles, all that kind of stuff, and we will synthesize a main method for you. And so, of course, I can put console write line hello over here, like this. Let me also put system in front of it, and instead of using a using, and that's the simplest hello world program that you can write in C# now. So that's called top-level statements. And there's a couple of goals with that, of course. Well, the first one is to make it easier for people to get into the language and to reduce the ceremony. On top of that, it also converges what we did with CSI, C# Interactive, to the world of C# within Visual Studio. So these two things are no longer really dialects of one another. We'll actually ask, like, how can I get access to args? Well, args is a magic variable that occurs top level. So you can actually access args as if there's a main method around it that has args. Yes, you can also return a status code, and you can even use async over here. I think when I do return, the IntelliSense is kind of busted, and it sort of thinks that I want to import this nasty namespace, but that's something that will be fixed before the final release. So I can do async in here as well, which we were able to do in C# 7.1, I believe. We introduced Async Main. So all this stuff really does under the hood is just synthesize a main method for you. So I'm just going to open up in ILSpy the thing I just compiled. I'm using .NET 5, so things look a little bit different when it comes to you know, how to find things. Well, it's been a while since, you know, we put things in source repos over here. I think it's console app 3. But one thing that also happens because we are distributing, you know, a launcher application together with a DLL is that all the code that you compile sits in this DLL, not in the exe. The exe is simply the wrapper that bootstraps .NET, so you don't have to do .NET, you know, .exe in order to execute console app. But that's a native, you know, bootstrapper. The real code that you wrote sits in the DLL next to it. So, so I'm just going to open that up, and over here you can indeed see that we've synthesized the main method with an unspeakable name, so you can't refer to it yourself. That contains all the code that you had, you know, written previously, top level over there. So that's top level statements. Okay. Next, you know, we'll take a look at another feature called record types, and I kind of want to ease into that, you know, step by step. So I'll actually start by just creating a person class like you've always done before. And I'm going to put in this thing a string name, you know, with, you know, let's say a getter and a setter, and an int age also with a getter and a setter. Stuff that you've been able to do since C#3, actually, those small getters and setters. Now, once we have this, obviously we can create a new person. I'm going to do that in my top level main over here. You know, I could put main around it if you like that better, but, you know, I'll just stick with my, you know, main method being invisible. And I can create a new person like this, you know, and I can, of course, set the name to Bart and the age to 21, which a little bit of a lie, but that's okay. And so, well, this is pretty neat, pretty nice syntax, because you can see that indeed, you know, Bart is the name and the age is 21. And you don't have the confusion that you have with constructor, where say that you take in two strings, like for the first name and last name. You don't quite see the order unless you use named parameters to make it explicit. So, you know, this syntax with object initializers that was introduced in C# 3.0 is pretty neat. However, you know, it kind of paints you into a certain corner. And what I mean by that is like, well, you don't get the chance to make this thing immutable. I can change Bart into John, for example, over here. I actually may want to have, you know, an immutable design where the object once created, I cannot change it anymore. And so if you had to do that, you kind of fell off a cliff. You had to go to constructors. You know, you had to make those fields over here, or those properties actually get only, which you could do since I believe we did that in C# 7 or 8 actually, which means those are read-only fields underneath. And they can only be set from a constructor. So then you have to create a constructor like this, you know, you can have string name, int age. You could use duple syntax with C# 8 or 7, actually 7, where you could actually, you know, assign both of these guys by doing something like this. But you can start to see that, you know, you have to write a lot more boilerplate code, right? I have mentioned in this whole thing name and age, you know, 3 times in 3 different places in order to be able to write this. And then, of course, I have to sacrifice this whole syntax. And now, you know, I don't quite know that the first thing is the name and the second thing is the age. Well, here it's pretty obvious. But now I have an immutable design. Can't we do anything that's a little bit better than all of this voodoo? And the answer is yes. We actually thought about this for a while, because like this is a place where, you know, one language feature doesn't compose with another kind of design trends, namely, you know, to have immutable data structures, which are very useful. And I'll talk a bit more about that in just a moment. So I would like to get back to this syntax. I don't want to have all of this ceremony, but I need to clearly have a way to say like, well, these properties can be assigned to, but only in the context of an initialization when I'm creating a new object. And so instead of having setters, you can now have what we call initters. Initters are pretty much, you know, the same as a setter, but the language actually enforces that you can only assign to those guys in the context of an initialization. So within those curly braces after person, it's totally fair game to assign name and age. But once you come out of it over here on the next line,
the door has been closed. You can't, assign to it anymore. The object has effectively become immutable. So it kind of goes to a little, crisis, if you will. It gets constructed, it gets mutated, and then once it's completely shaped to the shape that you want it to be, the door closes and you can't actually continue to mutate it. And so this allows you to build, immutable data structures quite effectively. Okay. And of course, immutable data structures have their benefits. Namely, well, you can share them as much as you like. You can share them to anyone in the world, and you don't have to be afraid that once you share this object over here, some person called Bart with age 21, that all of a sudden the age is going to change underneath, right? And because you can share it, you can reduce allocations as well, because like many objects can safely refer to this particular object without having the fear that it gets mutated under the hood. And in fact, what's going on in Visual Studio, all of Roslyn is actually built using immutable data structures. And so I'm not sure if I can pop up an example over here. Well, that's actually just a suggestion. But you've pretty clearly seen those dialogues, and we'll see them later on, where you see like, this is how we would like to change the code from this state to that state, right? That's all done using immutable data structures. The code that you're looking at over here is represented in Roslyn as an immutable syntax tree. And whenever I hit a key over here, it's creating a new tree. And so it has now two copies of the world, one that actually represents the old world before I make the edit, and one that represents the new world after the edit. And so that's a way to actually help designing these type of APIs. So now, well, I have this beautiful person object here. It has init only properties, which is a great addition. Can I do things, a little bit, even better than that? Meaning, I have this person object, but maybe I would like to think about, persons as something that I can still, maybe create a copy of and make a change to. I want to have a new person that looks like Bart with age 21, but I would like to change the age to 22. And I don't want to have invasive mutation. I don't want to mutate the object. I want to create a copy of it where one thing has changed. And so I want to kind of evolve the world from one state to the other state. So that's one thing I may want to do. A second thing I may want to do as well, what if I want these things to have, value equality? Two people that have the same name and age need to compare the same. Well, at that point, you're falling off a cliff again, right? Override, double equals, override equals, get hash code, override toString maybe as well while you're at it. Implement IEquatable, add an operator double equals, add an operator not equals, add all of that kind of stuff, in the code. So can we help you make this thing a little bit easier? Well, the answer is yes. If you make this thing into a record as opposed to a class, all of a sudden a whole bunch of magic happens. This record type actually still looks exactly the same at the use site. You can, initialize name and age, as you were able to do before. But on top of that, this person object actually has implemented a whole bunch of things for you. And we'll take a look, in ILSpy, what it has actually done. So it's compiling, here we go. So here I have my person object now. And the person object has, well, as you can see, slightly more than just a name and an age property. I have a whole bunch of stuff in it. But let's first actually start with looking at those init-only setters. Because if you look here in ILSpy, you actually see that those getters and setters are just looking ordinary. And that's because, ILSpy doesn't understand the new stuff in C#9 yet. But if we would actually take a look at the IL code over here, you'll actually see that the setter of name and age has this thing on it called a modifier, a required modifier. It actually says if external init. That's the thing the compiler uses to say, well, this setter can be called in a context where we're doing an initialization. It can't be called outside of that. And that's why you get those red squiggles that say, like, you can't assign to this after you've constructed the person object. So that's the little piece of metadata that's actually used in order to actually represent an init-only setter. But under the hood, it's really just a setter with some additional so-called modifier on top of it. So that's that part. And on top of that, we have actually generated a whole bunch of other things. For example, we have implemented over here IEquatable of person. So this thing has strong value equality. And that means we have to implement equals. And you see over here that the implementation of equals does a couple of things. And I'll ignore this equality context for just a second. We'll talk about it later. But it has implemented, you know, the equals the way you would likely do it as well. You know, use the default equality compare for string to make sure that name and the name of the other object are the same, and the same thing for the age on the right-hand side over here. We're actually also making sure that the age matches up as well. We've also implemented get hash code. So get hash code over here. Again, you know, uses the equality compare, the default for string and int to get the hash code for name and age. And it has this big number in it over here, you know, which is used to scramble, you know, the pieces of the hash code together to ensure some good distribution. Okay, so that's equals and get hash code. Obviously, we override equals on system.object as well. That's this one. And we also override toString to actually build, you know, a neat little string representation of the object. You know, person curly brace name equals Bart, comma age equals 21. And that's done using some helper method over here called print members that actually, you know, puts all these things together in a string builder. So that's pretty much what gets generated, you know, that you kind of would expect maybe to see if I say that this thing has strong equality and so on and so forth. But we also generate a couple more things. We see this magic clone method, and I'll talk about this in just a second. But as you can see, it's unspeakable. You can't call this thing yourself. So there's some language syntax that allows you to kind of use this clone thing. And so what does clone actually do? Well, clone actually calls person passing in this, which is what we call, you know, maybe a little bit like C++, you know, copy constructor. So there's this little constructor here that actually just clones the object because it's immutable. We don't want to have changes to the object. But if you want to make a change, what if we can actually clone the object and then do a mutation on top of it and then seal it again? All right, we sort of say, I want to have this person, but with its age being substituted from 21 to 22. Okay, so let me show you how that actually works. I have a person over here, right? And this is the old Bart. Now it's my birthday and I want to have a new Bart, and then I, you know, want to publish this guy. Well, I could create a new person, but that's not what I want to do because I don't want to like copy over manually the name and, you know, a whole bunch of other things like the city and the zip code and what have you. I would actually like this thing to be old Bart, just exactly the same as old Bart, but with the age being set to 22. And so now I have a new object, you know, that's completely identical to the original one. It's a shallow copy of the original, but the age property has changed to 22. So I still have the old guy sitting around over here as well. And so now I have a new one that just has, you know, this little selective mutation applied on top of it. And in fact, you know, if I now would say, you know, revert to previous Bart equals new Bart with age equals 21, well, then, of course, you know, I have a third one over here, but this one would be value equal to the first guy because it has exactly the same content. It's Bart 21 again, right? But this guy, you know, is of course not going to be equal, you know, to old Bart or to revert to previous Bart. So we have value equality, and we have those new with expressions that allow you to do selective mutations. So when I actually compile this thing, what you will see is that the code that, you know, does all of this magic inside my main methods, you know, that's where everything is going on, is actually using this clone thing. And on the clone that has been created, I can assign the age, you know, to become 22. But only the compiler can do that because it knows it's happening in a safe context where the object cannot be observed by anyone yet, right? Because, you know, it's not until this whole right-hand side executes over here that new Bart is available and that it can be handed out to someone. So we have a little island where we can do the safe mutation. Once the mutation is done, we assign it to a variable and you can't mutate it anymore, okay? So now you can safely hand it out, nobody can change it. You don't have to do synchronization, for example, with, you know, to protect against mutators and those kind of things. So, so that's actually the little with expression. And of course, you can also change other things in here. You know, we can change as many properties as you would like to using with expressions. This is a way to actually get us on the path to get better support for objects that have value equality. But you don't have to do all of this ceremony of equals, get hash code, equatable, all that kind of stuff. You also get a nice toString representation for free with this. And, you know, we sort of reduce a lot of the ceremony that you have to write over here. And in fact, you know, we're going one step further with this thing called primary constructors. Instead of writing all of this stuff over here, you can actually also put these things right over here. And beyond C#9, the goal is that like primary constructors will enable you, well, you can then call it using constructor over here, but primary constructors will enable you to refer to the parameters of a constructor in the whole body of the class without having to write a constructor. We will synthesize a field for you if you know, you're going to use it in a different method and so on. And so if you do something like this, you would actually be able to write, you know, equals name and equals age over here in any class or any struct. Now, you would likely not just want to do that because that's just a whole bunch more code. But, you know, anywhere in your code, you would actually be able to refer to name and age, you know, that came into the constructor without having to create fields. And if you want to expose those things as properties, you would still be able to, of course, assign a property to it. But, you know, with records, we go one step further. In fact, you can take all of that stuff away, and this will generate, you know, two properties called name and age. You will be using a constructor to initialize this guy if that's what you want. But that's called a primary constructor. So if you want to create an object that has, you know, a single constructor where things are positional, you don't use name, comma, age, you know, and assign those guys, but you want to do the world, you know, of constructors again, because that matches more your design goals in a certain case, then, you know, we can take away a lot of ceremony of having to write constructors and have to declare fields and properties and do assignments and all that kind of stuff. We can actually synthesize a whole bunch of things for you. And I'll actually stick with, you know, this one with init only properties that are assignable, which makes it pretty easy to see what's going on over here. It's safe for mutation, all of that good stuff. Okay, so that's record types. It's really a way of compactly representing a piece of data, and we're kind of looking more in that direction because in a lot of cases, you know, types just represent bundles of data. How can we actually make that smoother and easier? There's still a lot of ceremony over here, as you can see. You know, get and init will likely be very common combos going forward when people build immutable data structures. And like, you know, why do we have to have all of this, you know, ceremony over here still? We're looking into making that even more concise. Okay, so that's it for record types. I also want to talk a little bit about pattern matching. We've done a lot of stuff with pattern matching, starting with C#7, I believe, yes. And that's a language feature that's continuing to evolve quite a bit. So I'm just going to put in here, let me actually put it over here, static void demo, you know, and I'll just take in an object, you know, object O to just, you know, get somewhere, right? So the things we did before was like, you know, you can actually write, let's start here. You can write if O is string S, you know that now, right? You know, you can actually do the type test and actually say, if the type test passes, I would like to assign this thing to a local variable. That we did before, and that's pretty easy. Other things that you have over here is like, you know, you can do is for example, null as well, like this. So, you know, we have this is thing sitting over here. Now, what you can also do is like if you have these else if letters, ever since C#7, we allow you to actually do these things using switch statements as well, right? You can actually make this thing into a switch statement. And so everything that you can do with is also can be used inside cases, right? So like is and case is actually equivalent in language. The right-hand side of is and case contains patterns, and patterns can be things that type for that actually test for types, for example, like we're doing over here. And in fact, we can go one step further, and that's something we did before as well. Like say that, you know, I want to return 1 over here, return 2 over here, and then, you know, in the case of the default, you know, I want to return 3 over here. That's a lot of ceremony. So we actually do have switch expressions as well. And again, that's also that we did, you know, before. That enables us to be more concise like that. Now we have many more patterns than just type patterns. We have patterns that can match on the shape of tuples, for example. But let me just, you know, put in a couple more things here. Like for example, when the string length equals, you know, 1, I would like to do this. When the string length equals 2, I would like to return something else. when the string length equals 4, I would like to return yet something else, you know, whatever, right? I'm just making up some stuff here. Now with those run guards, you know, you can do quite a few things, but it gets quite repetitive because I have this s.length sitting everywhere, right? So what you typically would do here is, you know, as opposed to, you know, having all these cases be separate, you would likely refactor this thing into something like this. You would say string s, you know, goes to, whoops, you know, if it's a string s, I would like to take the length and I would like to switch on that and then say, you know, if the length is 1, then I want to have 1 come out. If it's 2, then I want to have 5 come out. And if it's 4, I want to have 10 come out. So you can nest those guys to kind of, you know, do the deep structural matching, right? You know, at the top, you're actually saying if it's a string s, then do this and so on. Now it's complaining over here that we're not exhaustive, like, you know, we're not covering all the possible lengths over here. So that's pretty good. And in the previous case, you know, we would actually fall through and we would check if the thing is null. We would check, you know, if it's anything else, and it would return 3. So, you know, let me just put the 3 back over here as well. Say for all the other cases, you know, I would like to return 3 over here. Okay. So I can write something like that, but say that you're doing something else, you know, say that you actually want this thing to be, you know, dealing with the cases of, you know, 1 and 2, and then you want to say, like, you know, it's larger than 10, I would like to do something else. You know, if it's larger than 10, I would like to return something. If it's, you know, less than 5, I would like to return something else, you know, and I kind of want to have, you know, relational checks here. Like maybe I want to compare the date time to, like, you know, the hours of the day. You know, if it's later than midnight, but earlier than 6, then it's night. And if it's between 6 and 9, then it's morning. And if it's between 9 and 12, it's like, you know, I don't know how you call that, but, you know, whatever. You kind of want to do relational things. Well, at that point, you know, we were not able to go here. You know, we were not able to, you know, capture these relational patterns in switches like this. Now you actually can. So you can actually put over here things like if it's larger than 10, if it's less than 5, you know, I would like to do something else. So we now have those relational patterns, and that makes it very easy to write things like this. For example, static bool is letter. Let's say I have a character over here, and I want to say that the character is letter. Well, that has to be larger than or equal to this, or no, and it needs to be less than or equal to z, or it needs to be larger than or equal to, oops, it needs to be larger than or equal to A, and it needs to be less than or equal to C, like that. And that's, you know, that's okay, but we're repeating that C thing quite often. And of course, in the context of switches over here, maybe we're repeating a whole sub-expression a lot of times. We're repeating like s.length multiple times, or we are repeating, you know, indexing into the first character of the string multiple times. So if you want to use that inside this switch, you know, this C really is typically not just a variable, it's something much bigger. So there's a lot of, you know, repetition going on over here. So with patterns, you can actually write something that says, if C is larger than this and it's less than C, or it's larger than or equal to that, and it's less than that. So you don't have to repeat that identifier over and over and over again. You're actually saying, you know, I want to compare C with this whole predicate. And we have ands and ors in here. We also support not. The reason we have to use different syntax than and or and not is because there's a lot of ambiguity if we have to use if we have to use that syntax. But the beauty is that you can actually put this whole thing in a switch as well. You know, you could actually have, you know, static void parser, you know, that takes in a character C. And now I would like to switch on the case where something is a letter, you know. Well, then you can actually say case, everything after the is, I can totally put here and say we found the letter, you know, and you can do the same thing for a digit. You can have cases that actually match all those constraints, because this is completely interchangeable. You know, is and case works totally in conjunction. So we have, you know, those relational patterns, you know, that allow you to do comparisons. We have and, or, and not, and those kind of things, and we still build out a switch table. So this whole thing is still very efficient as well. This also allows you to do things like this, you know, over here in this switch thing. Let me actually do yet another one, static void foo, you know, where I take in int x. You know, in the past, we had a problem here, like, you know, let's say you have switch x and you do, oops, sorry, you do something like case 1, return 1, case 2, return 1, case 3, return 2, let's say, and default return is 7. You know, I'm just making something up. It's a language demo, right? So if I do something like this, and I return int over here, we didn't really have a way for you to make this thing compact. We can change it to an expression, but you know, you have those repetitions here, like 1 and 2 are the same. And you know, in traditional code, you would actually have a fault where you would say case 1 and case 2, I want to handle together. You know, I don't want to have the same body here. I want to handle those cases together. So we didn't have syntax that allows you to convert this kind of switch to the more compact form. Well, now you can, right? Because we actually do have or. So you can say if it's 1 or 2, then I want it to be 1. So now we have or and, you know, all those kind of things. So you can actually build pretty sophisticated patterns over here. And I'll actually pull up a sample that we use in a bunch of places. I'm just going to copy it out of this little piece of code where we have cars and, you know, trucks and taxis, and we calculate, you know, the fare that you have to pay on a toll bridge or something, or on a highway. And so I'm just going to copy out the original piece of code here that I've just put aside to kind of show you the state of pattern matching. But so if I copy all of this stuff out, it's basically just a switch that, given an object that represents a vehicle, is actually going to check, you know, if it's a car, how many passengers do we have? If it's a taxi, you know, what are the fares? You know, some rate for fares. If there's a bus, like how much is it occupied? You know, based on the occupancy, we'll actually charge more or less money. If, you know, there's more people in the bus, we'll charge it less to go over the bridge and so on. But as you can see, we do have some repetition in these places, because we have, you know, things like this, like less than and greater than, and all of that kind of stuff. So with those relational patterns, you can actually make this much more compact. You can actually say, you know, bus B, and then you can actually say over here, I would like to switch on this particular value that I calculate once, and then I would like to say in here, if it's less than that, I would like to have it to be this, and if it's larger than that, I want it to be like that, right? And in the other case, if it's just a bus, you know, where I don't have any value to compare against, I want it to be 5. And so you can actually get things now into this much more concise form. Well, don't put 2 arrows, you know, like this. But you only calculate one thing, and then you can do comparisons against constants for equality, inequality as well, if you like, with not, but also the relational patterns that you have over here. And other things we've done, like, you know, if you have a variable, like for example, you want to see taxi, I could do the same thing here. I could switch on fares, you know, in a nested construct if I would like to do that. But this pattern also already worked in C# before as well, like, you know, property patterns. But, you know, for this remainder case here, taxi, that's fares not equal to 0, 1, or 2, I had to specify some variable name. And you know, we have the discard syntax ever since C#7 as well. Or maybe even C#6, but you don't have to specify that anymore if you don't care about it. You know, like, you can be a little bit more condensed. That's just a type pattern. So that's pretty much just saying if it's a taxi that doesn't match the criteria that we specified before. So you see, like, you know, things get a little bit, you know, easier over here. At the bottom here, we also had this ugly pattern, which is that matches any object that's not null. It's pretty much just a property pattern that says, like, this is something, an object that's not null, and I would like to make sure that the properties inside of it hold. Well, there are no properties in this case, so it means any object that's not null. It's pretty much the same as this, you know, taxi with fares, but without specifying fares and without specifying a type. So now we can also say over here, you know, it's for the not null case that I want to deal with, like this. On top of all of this stuff, we actually do exhaustiveness checking as well. We've already seen that before. If I don't handle a certain case, it will actually complain. But also if, like, you know, if I, like here it says, for example, the pattern 3 is not covered. So it sees that we do 0, 1, and 2, but we don't see anything that covers 3. If I put in 3 and I still don't put in a catch-all, it will say I didn't find something for 4. It's telling you that this thing is not exhaustive. You have to make sure that you cover all the cases. So it helps you with that as well. But you could also have something like, say here, if it's less than 0.50, then I want to do this. And if it's like less than 0.30, I want to do like 12 or something, right? Well, it's going to say the previous case is already dealing with it. You can't match less than 0.3 if you've already done less than 0.5. So it's actually going to say like this is unreachable code. So because we have all those relational patterns, we can actually piece together the whole domain and actually see that you're dealing with all the possible cases as well, and you don't have overlap between which you may not intend, or you may not even realize that the code was incorrect to begin with. So that's pattern matching. So in a nutshell, we do have the relational patterns now. We do have the type patterns, which is pretty much just so that you don't have to write an identifier here. And we also do have and, or, and not that allows you to do things like not null. And so a simple way of doing a null check now, that's reference equal and not calling an operator overload and those kind of things, is simply to use not null, right? You would actually write something like, like this over here, if O, in the past you would actually write this, like, if O is null, right, I want to do something, okay? And that would work totally fine, but if this is an object like, say, I don't know if I want to use person here, but like some object that has an operator equals defined, you're calling custom code, and maybe you just want to check that this thing is not reference equal to null. At that point, we said like, is null is a good way of doing that, because that just checks for reference equality with null. But in the past, like, if you want to do something else, you want to write some code over here. In the case where it's not null, then it wasn't really that great to have to do is null and then put a not in front of it, right? That doesn't really flow very well. So now you can actually, you can actually write is not null, which is a negated pattern like this. So that does a reference equality check for null. But in this case, it's negated, right? And you don't have to have this, ugly additional set of parentheses as well. But again, these things actually all fall together with like all this pattern matching. So like examples of something like is letter over here is maybe, reasonable for you to write it that way. I like the conciseness and the clarity of it, not having to repeat C all over the place all the time. But you always have to think about, all these is expressions to also, fit in a bigger context of switch statements and switch expressions. And so by putting them over there, you can build these pretty sophisticated things. Let me actually just compile this once and take a look at the generated code for a minute as well. It's still building. It's taking a little longer than expected. In the meantime, I'll just go back here and I'll just pick out a couple more little things to briefly talk about. So one more thing that we do have, like there's a lot of stuff going on with regards to performance. Ever since C#7, we've done a lot of stuff. We've worked on structs, to have ref structs, read-only structs, those kind of things. We enable things like span of T, which allows to avoid a lot of allocations. So there's a couple more things that have come up with regards to performance, just a few. And there's really, I would say, like 3 in this bucket. We have this thing called skip locals init, which is a very advanced feature. But especially if you're writing some low-level code, you're doing things like stack alloc, you can actually avoid the CLR to initialize data to 0 by default, even if it's not a type hazard. And what I mean by that is, I'll just give you an example. If we can go back to ILSpy over here. Let me first show you all of this parser code that we had. Actually, it optimized it out because there was nothing reasonable in it. But like over here, for example, where I did the or thing, 1 or 2, you see that it really just becomes a switch statement in the traditional sense. And this whole demo CO where we were doing all those comparisons, like whether it's a string with length 1 and length 2 and all that kind of stuff, it actually rewrote the code into like, a decision table that's constructed in such a way that, all the cases are like, disjoint of each other. So you see, like, if the length is larger than 10, we do this, else if it's less than 5, we do that. We didn't build a table of all the integers, of course, like, where we said, like, we're covering 1 and 2 and then less than 5, so we have to have a label for 3, 4, and then we need to do something for 5, 6, 7, and 8, and so on. Like, yeah, we didn't do that. We built a whole bunch of, if statements that kind of nest and don't have overlap. So that's how that works. So going back to this locals init thing, oops, everything is actually kind of going very hectically here. Let's go back to ILSpy. Sorry for the all the noise here. If I go to IL over here, you see this whole thing at the top. It's something that C# has emitted, historically since the very beginning. And what this does is actually tell the CLR, well, look, we have a whole bunch of locals over here. I would like all of these things to be zeroed out before I can access them. It turns out that the C# language is actually a little stronger. You're not allowed to access, a local of type bool or int or whatever if you haven't assigned to it before. You need to have definite assignment before you can read it, which actually means that, like, you cannot even see if there's garbage sitting into a local variable. If you have a local variable X, you can't access it before you assign to it. But this locals init thing actually tells the CLR, I would like these things to be zeroed out. So not to have any kind of surprises in languages where you can read from something that's uninitialized, and that's not the case in C#. But we do need to zero out a whole bunch of other things. We need to zero out things like strings and objects, because these are references onto the heap. And references onto the heap need to have an address that's valid. And if the address is not valid, well, the garbage collector will completely blow up. It will traverse something that does not exist and in invalid places. So we need to null out references for sure, but we don't necessarily need to zero out a whole bunch of other things. Now, in some very performance critical code, this may actually show up, this extra cost of zeroing out things. So now we have an attribute that you can stick on methods that are performance critical to actually say skip initialization of locals. Don't zero them out, because in C#, you can't access something unless it has been assigned to. So it's kind of safe still in that regard. And the CLR will still zero out all the reference types anyway, because it needs to do that for type and memory safety. So it actually avoids the cost of nulling out the other things. Now, in a lot of cases, it doesn't matter. It mostly matters in cases where you are already doing some native code, and you are using this keyword called stackalloc in an unsafe method. In that case, there's a lot of cost associated with that. You're, allocating a piece of data on the stack. And maybe, it's a pretty big chunk of data, and you don't need to zero it out, because what you're going to do is you're going to assign into it immediately. At that point, you can actually say, well, dear CLR, you don't need to zero this thing out. I will take care of it myself. And so with this skip locals init thing, which is just an attribute, actually skip locals init like that, you can actually say, like, don't emit that directive into the code, and the CLR will not do this skipping of initialization of locals. So that's a little performance feature that actually helps for some stuff in the .NET framework itself, in the .NET base class libraries. Another thing we have is static lambdas. If you have a lambda, it can create a closure, as you know. So like if you have object, this thing over here, this demo thing, say that I create an action A equals nothing goes to console right line of O. Well, here you have like a hidden heap allocation, because O is used in the body of the lambda. So it's actually creating a closure over here. It's also suggesting to use a local function, but that doesn't quite matter in this context. It will have pretty much similar performance profiles if ultimately you want to create a delegate. But so if you have a lambda and you want to be darn sure that you don't have any allocation happening here, you can actually put the static in front of it. And now it will say, well, if you want this thing to be static, well, you can't capture O anymore. You can't do that, because this requires us to do a heap allocation to host that object O so that its lifetime can actually be longer than the current stack frame and can be used, throughout the lifetime of the delegate. So if you put static on a lambda, you actually avoid creating closures, and of course you have to deal with it in such a way. Maybe in this case you could pass it in, pass it into the lambda and then use it to a parameter as opposed to having it been captured. So that's the case for static over here. You can also put it on anonymous methods using the delegate keyword. It's just a way to kind of, not have to look at every single lambda and see, does it contain any captured local from the outer scope? If so, there's a little performance hazard here. If you put static on it, the compiler will ensure that for you. And when you do a code review, you can see, well, this delegate doesn't really cost me much. So that's the static lambdas. One more thing that we did in terms of performance are actually two things. We have native ints. Native ints is not really a performance thing, but if you're doing a bunch of interop code, which likely most people, don't have to do that much, but if you're kind of on a layer where you're interoping with native code, you typically use this int pointer type, right? Int ptr or uint ptr, which is a machine-sized pointer. In my case, will be 8 bytes long. On 32-bit it will be 4 bytes. We now have aliases for that. Nint and uint for native int and native unsigned integer, with all the operators defined. So like for pointer, arithmetic, and so on, we do have plus and subtract and all those kind of things, and we do have the conversions built in. So to make interop code a little easier, we do have nint and uint. And then there's also this thing called function pointers. I'm not going to show that one, but we have a new syntax to actually allow you to represent pointers in the C style way, which can be used to refer to native code, but also to managed code, to allow to do direct calls to things as opposed to go into levels of indirection. And that's again, for some performance cases. So with that, we've kind of covered, the performance set of the house. I'm just going to talk about two more things really briefly. We have target type new. Target type new is the thing that allows you to actually gives you more flexibility in the way you initialize things. So like if you have person, that we had before, something like this, person p equals new person. That's in C#3, we allow you to use var on the left-hand side, right? To avoid having to write this whole thing multiple times. And so that's pretty neat, especially if the type is clear on the right-hand side, that's a good option to use. We also had something, with defaults. So like, if you have person q equals default of person, a couple of releases ago, we actually said, well, here you have repetition 2, you could put var on the left, or you could actually get rid of, the person in between parentheses on the right-hand side, because we can infer the type from the left-hand side, right? We can see it's a person and you want to have a default of it. In this case, it's going to be null, so you can just put equals default here. So you can kind of choose the way you would like to do things over here. But what we don't really have is the way to actually say, I want to have a person z equals new, and then, I would like to create a new person, and don't have to specify the type on this side. So here we can actually do target typing of new, meaning on the left-hand side, we see that you want to have a person. On the right-hand side, we can insert the person for you. Now, why would you want to do that? Well, there's places where this leads to a much more concise form than the first case. But it's actually already shorter than the first case a little bit, as you can see. But if you have something like a person array, let's say people, and you do person over here, right? Well, you can either do this, you can say like new array and then new person number 1 and new person number 2. And of course, you would put things in between the parentheses to call a constructor or whatever. I'm just using the default constructor here. But you have to repeat that type for every single element, right? We already know if you put over here that you want to have a person array, that all of the things you want to put in the person array are persons, So like we can actually flow the type down and actually say like this whole thing contains person objects. Like, every single new in here means a person. And so, instead of having it being, linear in the number of elements in the array, you can actually write something like this, and you only have to mention person once in this case. So that all goes to like conciseness in the language. You can kind of pick your poison. And in fact, we do have, a lot of these light bulbs that actually allow you to switch back and forth between different forms, right? Like, I don't like var here, let's get rid of it, let's do it this way. I would like var here, do that. We also have a bunch of refactorings that automatically will figure out, like, if you have those repeated forms here, like new person everywhere, it will say, did you know in C#9 we can make this a little bit easier for you, and we'll just offer you up with making the change on your behalf. So that's target typing new. That's this guy. Discard parameters, not too important. The last one I want to mention briefly is covariant returns. So say that you have a class, class foo, and it has a method in it, that creates a foo, let's say, like this, right? Let's say new foo. In fact, we could just try new over here, with target typing, because we know we're going to return a foo. But say that I create a class bar, and let's make this thing virtual. Create a class bar over here, and I would like to override this foo thing, or this create thing, like this. And I'm just going to create a new bar here because it's more derived. I want, in this case, it to return a bar like that. I could use the arrow syntax, I guess, to make it more concise. You have to stick with this, less derived type over here. So if somebody's using bar directly, like somebody's using bar directly and calling create, well, even though it in practice creates bar instances, you would still get a foo back, right? Because it's an override of a virtual. And so then you would have to cast it, and you wouldn't know if it's really safe to do so, yes or no. Now we actually allow the return type to be covariant, meaning it can be more derived than whatever the base class specifies. And so only if you call bar.create, you will get a bar back. If you call foo.create through the virtual, you will still get a foo, of course. But now, when you call this thing on bar, you will actually get more derived type back. And so you don't have to insert those ugly casts in places. In fact, that's something that also came up in the Roslyn compiler. We have this thing called C# compilation, which derives from compilation, because we also have Visual Basic compilation. And the override for the factory method of that thing, returned the compilation. So everyone who was just using C#, to write code analyzer and so on, had to insert an ugly cast. And so this thing, you no longer have to do that. So to wrap up, and then we can have a quick Q&A as well. We have done a lot of stuff in terms of conciseness for things like pattern matching. Records are also about reducing ceremony when you want to deal with like value equal objects. Then there's a bit of fit and finish things, that deal with things like target type new. Lambda discard parameters are just a convenient way to ignore parameters in lambdas. We have done some low-level things like function pointers. We also support module initializers now, which has been in the CLR since the very beginning, but there was no way in C# to actually access that. So you can now stick an attribute on a method and say, I would like that thing to run when my assembly is loaded effectively. And then, there's a lot of smaller things, like, for example, extension getEnumerator. If you have a for each, it can pick up an extension method called getEnumerator as well. And I think there's a JavaScript coming up here as well. And other than that, we have this thing called top-level statements, for example. That's also about conciseness of simple code, make simple code simple. Going forward, in C#, C# next, you see there's a bunch of things already lined up. We want to do a couple of things to make null checking a little bit easier, so you don't have to write this, is null thing throw argument, null exception all over the place. Maybe you can help. We can help you a little bit with that as well. There's some more stuff happening with caller attributes. That's something that came all the way in C#4. We're extending on that a little bit more, so you don't have as much magic strings in your code anymore in certain places. But there will be a lot more stuff coming in C# next, which likely will build on top of records, things like primary constructors and so on, to make working with data a little bit easier. There likely be still some minor improvements as well to pattern matching, you know, some fit and finish work there. So with that, that's kind of, you know, a whirlwind tour over C#. I would recommend you to install the latest preview of Visual Studio 2019. Come to the Roslyn site, come to the C# Lang site, or come to the MSDM site where we have the C# 9.0 specification proposals. They're no longer proposals, they actually have been merged. But so here you can actually see basic examples of all these things that we talked about. Give it a try, and I would definitely recommend you to also open up ILSpy and actually take a look at, you know, the equivalent code being generated. It can be very enlightening when you take a look at a piece of code to actually see like what's the equivalent code I would have had to write before, which helps you to actually see the motivation behind language features that are kind of terse in syntax, but really help you to avoid having to write a whole bunch of boilerplate code. Okay, so with that, let's actually see. I don't know how to do you know, Q&A over here. I see a more button, but maybe I can give control back to Luke or ask him to take control from me.
Yeah, yeah, we've had a few questions come in.
Oh, good.
Only a few, which is
yep.
been very in detail and descript. Firstly, thanks.
Let's see.
Thanks for
the font, yeah, that's a little bit unfortunate. I'm sorry about the font. I hope you had something. We can do it again. Does the file need to be named program.cs? Can it be different? Doesn't matter. That's for the top level statements. Can be anywhere in the program, but you can only have one place, you know, in your project where you have top level statements. If you don't have top level statements, if you have it in multiple places, we don't know how to put them together, of course. So just like you can only have one main, doesn't matter in which CS file it is, you can only have top level statements in one file, and that becomes the main method. In practice, I think most people will just put that in program.cs, obviously. That's nice to actually find. How will records work with entity framework? Well, that's a good question. Well, at the bottom, they're really just classes. You can actually overwrite a lot of the behavior that's automatically generated. So, you know, you can put attributes and all those kind of things in places where you need to. They will work with serializers. You know, it's really meant to be a feature that captures data really well. Now, one thing, of course, when you deal with entities is the question whether value equality is really the thing you want, because maybe you're dealing with like a relational database where the equality of records is based on an ID property, you know, the primary key of the object, as opposed to the contents of everything. Like, you know, in a database, 2 rows are not necessarily the same if all the columns and the values in all the columns match, right? So, so that's something for folks like Entity Framework to decide, like, you know, what's a natural mapping with things like record types? Do they have the semantics that align with the semantics of the database? Yes or no? But it's really meant to deal with data in a more concise way, with less ceremony on the C# side. Clem was asking, are and or and not special case logic rather than using that? Well, the problem with and, you know, the traditional syntax in this context is actually that patterns can contain expressions as well, and so it becomes incredibly ambiguous if, like, you know, you do have and or and not in there as well. So it was kind of a decision that had to be made, like what to do, and, you know, ultimately the language design people said, well, and or and not are not that bad in the context of like a new place in the language, namely patterns. You know, within that, they actually do have special meaning. They're contextual keywords. They don't mean anything special anywhere else but patterns. And so, so that actually avoids a whole bunch of ambiguity. Are parentheses used? Yeah, you can do parentheses. There's the traditional precedence, you know, and goes above or and not is more important than any of these. But you can put parentheses as much as you like, yes. Would love a way of not having to check if a dictionary key exists in order to increment, update, or initialize. A way of not having to check if a key exists. Oh, I see. Yeah, I think that's more of maybe an API kind of thing. That's something we maybe if you have more context on the type of code that Andrew is thinking, that's something that I would have to think a little bit more about. I see most changes appear to make syntax more concise. Why not SAP is not null as well? It's not, oh, I see, like more like the C++ or C style, you know, where like, you know, if X, you know, that's a little bit, you know, yeah, anti-language, I think. You know, the way to think about the is not null is just like really, you know, the typical place where you put these things is inside inside switches, because over there, like, you know, by default things are dealing with equality, and so you want to have the ability to do negation. If yes or no, you want to use is not null, you know, inside an if statement. That's of course, you know, an option that you have. It's up to users whether they like that or not. Compared to the not equals operator, which may actually call custom code. Maybe there will be more conciseness there, but you know, the thing that's actually coming up is, you know, the most common case where you actually have to deal with those null things is argument validation, right? And we already did a bunch of stuff with nullable reference types in C#8 to kind of prove at compile time that something can't be null. So like you have object and you have object question mark, right? So you can say like this thing can be null. But you know, if something should not be null and you want to check and you want to have argument null checking, we're actually thinking of adding a syntax like maybe something like double exclamation mark, because we already have exclamation mark for the suppression operator to say like, darn it, this thing can't be null, right? We may have a syntax that actually says, I don't want this thing to be null. You deal with it at runtime as well. Insert a null check. You know, you don't have to write if it's not null, you know, or is null, then throw argument null exception. So so that's something that's being considered for C#10 to actually say, can we automatically generate all those null checks for you, so you don't have to pollute your code with them. And so that would be something that's, you know, better than all of that. Or something like not null. Maybe, but yeah, the problem with the exclamation mark is, again, there's some ambiguity, because not null already means something today. It means something that can't be compiled actually, because null doesn't have a type. But that's a different kind of expression, and so it doesn't necessarily fit well in the language. And any more questions? We can also open up the microphones, of course, if somebody wants to ask something in directly.
No, if that's all it.
Okay. Mm-hmm. Yeah. So yeah, I would just recommend you to download the latest Visual Studio Preview and give it a shot. Have a look, you know, definitely on. Why shy? Yes, everyone's shy. Yeah, definitely have a look on the C# Lang repo. There you will find, you know, what's going on. Also, if like you have any particular pet peeve or something in the language you don't quite like, you know, don't be shy. Just go there and open up issues in the issue tracker. And there's often a lot of traction. People will upvote and downvote things quite eagerly. Let me just, you know, show you the discussions that are happening over here. I'm not sure if I can find one, you know, that's a good example. But yeah, anyway, like, you know, you go over here, you file issues, and then people are pretty vocal. Like, you know, this thing was posted a couple of days ago or 2 weeks ago, and there's already a pretty big discussion going on. So, you know, just find your way to the GitHub place. The people on the language team are very reachable these days, you know, because everything happens in the open. And, you know, if it's a good feature, you will actually see a lot of thumbs up. Sometimes people will use different emojis to express, you know, their opinion about things, but people are here to actually look at it and pick these things up for future versions of C# and give them considerations. And in fact, a lot of things that you've seen today have actually come in through the issue tracker over here, where people say like, yeah, there's a lot of ceremony that we have to go through to express something, you know, pretty easily, you know, from a, you know, point of view of you thinking about it, it's easy, but from language point of view, there's a lot of like syntax that you have to go through. And so, so a lot of things come actually in through the issue tracker. And I've typically then put together to make it a concise feature that kind of fits together with the philosophy of C#. So please find your way to these places. I hope to see you again at some point, hopefully in person, you know, after this whole lockdown situation is over. But thanks for your attention.